Hi, everyone. My name is Berwout. I've been a professional software developer now for about 3 years, so not very long. So take whatever I say with a little bit of your own senior view, I guess. Today, we're going to be discussing a classical Greek myth in a modern jacket. And the myth is the one of Orpheus and Eurydice. And the myth goes as follows. Orpheus is a great lute player, so great that even the gods loved Orpheus. But he was madly in love with Eurydice. And she went for a walk in the forest and got bitten by a snake. And then she died from the poison from the snake and got sent to the underworld. And in the underworld, Orpheus wanted to bring his loved one back at all cost. So he took a boat across the Styx and he went into the underworld to pass the three-headed dog, Cerberus, and to bargain with Hades about letting his loved one out of the underworld. He won the bargaining, and Hades said, you can take your loved one out of the underworld, but on the way up, you cannot look back. And if you do look back, she's going to be lost forever. So here we see Orpheus walking out of the underworld and Eurydice behind him. And at the end, he doubts the view of Hades, basically, looks back and loses his loved one forever. We're going to look at it in a slightly modern jacket. Hopefully, my clicker will move forward to the next slide. And we're going to have a bit of an overview. So we have the snake, and the snake represents the we have Orpheus and Eurydice, the one we love. Orpheus, that's us, the programmers. Eurydice, the one we love, is our applications, or basically the stuff we maintain. And then we have the snake, which is the introduction of chaos into our environments. And it slowly poisons and kills our productivity, basically. So it ends up in the underworld. And then we have to go to great lengths to bring our applications back up. So Hades represents our product owner. He's the one we need to bargain with. And it's not easy to bargain with your product owner all the time. And it so happens that my product owner in this period literally looked like that, except did not wear a toga. Cerberus, the three-headed dog we meet on the way down, is also representative. It's representative of the fear we have in changing the way we deploy to production or the way we interact with production. So it represents a sort of barrier of fear of the unknown and also of changing our production environment. And finally, we have the slow creeping walk back up, which will have to be taken step by step. So first, we're going to look at the depths of hell. Where is our application environment currently residing? Why is it hell? And for every one of you, that will be a different type of hell, but some of the problems I've had in my personal hell might be relatable to yours. We're going to look at 5 steps up the stairs that we took in those 2 years, and we're going to evaluate how they worked out and whether they were nice, and how we convinced Hades to let us take those steps. And then we're going to take a look back. And right now, the truth is, I did lose this application environment forever because I started a new job. And in the story, Orpheus also, after losing his beloved one, he cries a lot and he sings a lot of very sad songs, and the crowd lynches him. I will be singing some sad songs, possibly. I hope you will not lynch me at the end of this presentation. What did I do? I was a platform team engineer when I entered, which meant that basically we sent production environments to teams that were building software. So I supported software engineers by giving them all the tools we need. We did all the hosting, the security on the environment. We did development of integrations between those tools so that it automatically registers your tickets in the source control and all that sort of stuff. We did automation so that with a click of a button, I could give you a new environment instead of having to manually roll it out. And we did support on the phone. We had about 5,000 or 6,000 developers on the platform. developers can be some of the most challenging users you have because they think they know better than you, usually. And having them on the phone is also, it's sometimes a challenge. So what did hell look like for us? So when I started in the team, there were 3 of us that did all those responsibilities we had there for the Java portion of the developers, which was about half of the developers. We had a bunch of expedites because developers are always in a hurry. They need their deployments to work. So they need your help and they need it now, basically. We had some manual rollouts because not everything is automatically automated, which means that people have to click buttons and people misclick and environments get misconfigured, all that sort of annoying stuff. We had a bunch of different applications. So we supported GitLab, Jira, Bitbucket, all those different ones because developers like choice, but also like if it crashes, it's going to crash and burn in a different way. So all those applications will burn in many different ways. We have those undocumented legacy features from when years ago there was no administration and developers still needed their build servers. So they were rolled out, they had custom plugins, they had all sorts of great stuff that you really want to maintain. We had unhappy users on the phone. Usually when people call you, they're not like, oh, you did amazing, so I just wanted to call you and tell you that. Usually it's because their stuff is broken and they want you to fix it right now. And we had a bunch of security features and updates because these companies like the Jira, Bitbucket, GitLab, they're pretty good at doing what they do because they also work for software developers. So they have regular updates on all these features. And when there's new features, your developers are going to want those new features. So you're going to have to roll out the upgrades. So basically, we were dependent on a lot of different companies, many different tools that work in different ways. And we had to make sure that it would still fit with our integration environment and our automation in a way that it would keep working. So what would regularly happen is, for instance, GitLab would update. They would update their API or something. And 3 of our environments would break down because they updated their API. And it would take us a week to fix it. Not very great, and I think you can relate from a software perspective as well. The libraries you depend on, the containers you depend on, probably the runtimes you depend on, they change, your stuff breaks, you don't know why. It can be very painful. So we're going to look at how we can structure it in a way that it hurts us less. It's always going to keep hurting us. That's, I mean, life is a struggle. Before we start, I wanted to start with this because this quote, it is applied throughout these 2 years. When I look back, the reason we were the way we were and the solutions we chose was because of the way our environment was structured. So it gets used in 2 different ways, this quote. One is, it is smart to design according to your communication barriers. So like, it is smart to design, for instance, if you have an API that talks with a different team, it's smart to version those and to have a barrier in between changes. So it's kind of smart to have your communication barriers also be the barriers of communication in your software, because otherwise it gets very difficult when you need to upgrade stuff because you need to talk to everybody, basically. But on the other hand, it also gets used to say that you are doomed to fall into the same structure due to your organizational structure. So the organizational structure matters. And I wanted to mention that, but I also hate it because it is something I can usually not change as a developer on a team. So we're going to look today at what we can do on a team basis, at what I can do to change my environment. But we have to see it in a way that this stuff also matters, except we usually cannot change it. So if we do have the opportunity to change it in a way that would be better for us, take that opportunity. All right, so the first step we're going to take up is a look at our way of working. And that's because when I entered the team size increased because we were swamped by expedites, and they wanted to solve the problem that we were only working on manual rollouts, expedites, day-to-day business, except instead of developing our platform, basically giving new features to the developers. So I put chaos rules on this slide, and it's actually two sides of the same coin. We introduce chaos by having a bunch of different things in our environment. For instance, having a larger team size introduces more chaos into your environment. For the same way, the complexity of our environment also introduces more chaos, like the amount of things we depend on or the amount of things we lease from other teams. The junior to senior ratio is one, like when I come into a team, you want to be treated equally, but it does matter the fact that I had 0 years of experience before I came in there. It matters, and you sometimes see it reflected in rights to who can push their code or who can push the production or something like that. It is something that introduces chaos. Production also introduces chaos because it can break in a million different ways. And the reason for the second world rules is that an environment that is more chaotic requires a more structured and deliberate approach. So if you have an environment that is more chaotic, you're going to need some more rules, right? But as software developers, we usually hate rules because they're also restrictive. So you should only implement rules until there is an amount of chaos that you can manage, because rules also kill creativity and they kill your workflow. So we had a critical way at a look at our way of working, because I entered the team, but with me 2 other engineers entered the team. We went from a team of 2 to a team of 5. And it works together very differently, as you can imagine. The first thing we looked at was different Git workflows. We started with a trunk-based development flow, which is everyone commits to master. And because there were 2 people initially, you could just say, hey, take a look at this change set I made. One could sign off on it. It's on master. Nice, right? It's the most easy kind of flow you can have. You commit to master. There's no complexity whatsoever. So it's preferable if you don't need anything else. Trunk-based development also gets used by fairly large companies, but they've usually invested a lot into build infrastructure where they manage away the complexity of, instead of putting it in Git, they put it somewhere else, basically. So it's a choice you can make, but you need a large build infrastructure to be able to run change sets or specific change sets if you want to do it across a large company. Feature-based development is the one most of us use, I assume. Can I see some hands who uses feature-based development? The idea is you make a branch for every feature, and your pull request gets submitted and you review it. It works well on the mid-level where you have a reasonable amount of complexity and you need to maintain a reasonable amount of applications. What you see in a very large company sometimes is multiple main lines. I'm personally not a big fan because I think it puts too much complexity into Git. It actually means that, for instance, when you have multiple major versions that you have to support of the same application, you would have multiple main lines of Git branches, and you would merge a patch into each of these main lines and deploy it using maybe a release branch or something like that. It puts a lot of complexity in Git, and it can be painful because there's a lot of extra actions you have to take. I have to think, do I have to put this patch in this version, where do I put it? It's a bit complex. Because we were a mid-sized team with, we did have a lot of applications, but we didn't really have to support multiple mainline versions. Thank Hades for that, actually, because he just said no. Like, we were too small of a team. We cannot manage having multiple major versions of all the tools you want, basically. And he took very good care to torch the old applications in time. So he would warn developers, you're still on Jenkins 1. If you don't migrate to Jenkins 2 by the end of the year, your instance is torched. Which is actually great. I like him very much for that. Some other changes we implemented because we had trouble dealing with expedites. We went from a Scrum flow, which with production environment sometimes kind of hurts because you require yourself to set a set amount of work you're going to do, and the first expedite that comes on goes into the next sprint, so it has to wait for 2 weeks automatically. What you do see happening is that some people budget into their sprint a certain allowance for bugs or that sort of thing. For us, that didn't really work because we had such a large production environment with 5,000 developers working on it, that some weeks there would be so much work there would be no sprint, and other weeks there would be almost no work. So for us, switching to like a Kanban flow with epics from the top to the bottom, where expedites flew through the top, it worked much better for us. The second step we took was we went from single branch pipelines to multi-branch pipelines. We had about 35, 40 products, maybe 50 or 60 Git repos. Each one of them had a Jenkins pipeline. And having them all on master started to hurt when we went to multiple developers, because sometimes you're working on the same feature, you want to use the same branch, it doesn't work, or somebody switches it to a feature branch in order to test whatever they're testing on that feature. And it really hurts when they forget to set it back. And you're like, oh, why is my change not working? You're running your Jenkins pipeline. It's kind of painful. And there was a lot of manual having to switch the pipeline back and forth. So basically a very easy step was multi-branch pipelines. And it didn't take much to convince my, my PO of that, as you see in the corner. Because it gives us the ability to test features independently. It works great with a feature-based flow. If you have a different Git flow, that's why the Git flow is best to do as a first step, because everything else is based on that. There's not a very high cost of implementation. It's basically making a different item in Jenkins, and most of the products support it, even like GitLab and Bitbucket have multi-branch pipelines. And it has relatively little added complexity. You can reason about it quite easily still, because you're already reasoning in a feature-based way. Why did I include it when it's so obvious? We had this great mechanism that we implemented also to border the chaos a little bit, which is that my PO allowed us 4 weeks of world improvement time during our, 4 hours of world improvement time every week, not 4 weeks, my bad. 4 hours every week. And you could do whatever you want, but you would have to announce what you're going to do, and you would have to take responsibility for what you did. So I went ahead and I went, I can do multi-branch pipelines in those 4 hours on a Friday afternoon. Turns out, because it was 50 Git repositories and 50 branches, that I got stuck somewhere in the middle. And I ended up having to clean it up the next week, Monday, Tuesday, and Wednesday. And it cost me a lot, because I had this, this freedom and this responsibility for those 4 hours. And my PO was like, yeah, but like you start something in 4 hours and our build doesn't work until Tuesday. So he got quite angry at me for that. And it led me to this advice: try not to sneak around when you're going to build. So not asking the PO and then ending up in a situation with your pants down is not a great way to earn trust. The third step, and perhaps the most interesting for all of you, is a monorepository. Because we had so many different products, the idea that we could test those changes in multiple products together for us was a great motivation to go towards a monorepository. Here's a tweet from Matt Klein. Can you read it? Oh, all right. So Matt Klein is a much better programmer than I am. He works for Lyft and he designed the Envoy proxy, amongst others. And he says it's sort of a religion, which I'm not really going to dispute. So first, I'm going to convince you why it is sort of a religion, and why it is actually more difficult than just putting your stuff in a single monorepository. So we're going to think a little bit. For my PO, the promises were that we could review change sets that hit multiple products in one pull request, which is very valuable because you can see which changes affect each other in a single pull request. It's really nice. You can build the minimum. When you change 2 products, if they depend on 3 other products, you only have to build those 2 products, pull in the 3 extra products, and test them together. But you don't have to build the whole stack every time. So you can build much more efficiently. And you can automate testing across multiple products. So you can set up a deployment where it's going to deploy whatever minimum you select, and then it's going to test those things together. And that's very powerful because if you have single repo pipelines or anything, you're going to have to do that orchestrating yourself. You're going to have to pick the products that you want the branches to run from, and you're going to have to deploy them yourself, and it's a lot of manual work. So this one for us, the last one especially, was very valuable. But when we started to build, we were like, okay, so when you run a build, what do you actually want to build? Let's say we have a master and a feature branch here, and we're on the feature branch. We actually sort of want to change we want to build the changes that we made in comparison to master. That makes sense, right? But we don't really want to build the changes to the most recent master over here. In reality, we do want that because we want to test, does it currently work if we merge it? But if we test it with the most recent master and someone pushes a commit, it's going to change our build every time. And our build is going to have like a shaky underground where you don't really know what's going to get built. And someone is going to change your environment while you run. So if someone changes a product, you're going to have to build it on your feature branch all of a sudden, which is kind of weird. So you want to build the difference between this commit over here and the common merge base that you have. But if you consider what do you want to build when you're on master, when you're on master, you kind of want to build either everything, but you don't always want to build everything because, like I said, you can build the minimum. You only have to build what's changed. So on master, you kind of want to build the previous commit. You want to build the changes to the previous commit, or not exactly the previous commit. You want to build the changes in relation to the most recent successful build, right? Because the changes in that successful build, you already tested those. So you're going to have to figure out what was the last build that succeeded and what were the changes that I have compared to the commit of that build, right? You also want some flexibility because when you're developing, you want to be able to say, okay, right now, I don't care. I don't really want to run this whole test suite. I just want to see if this build works. For instance, if you're working on the build. So you also want some sort of flexibility that you can say, I only want these products to build, or I only want these tests to run. You can already see maybe that you're going to build something that's custom because your GitLab or your Bitbucket or whatever is not going to support this kind of customization. This is why if you don't feel comfortable in CI/CD and your team doesn't do a lot of CI/CD, this might not be the best solution for you. So here, the nice thing is Git has commands for this. You can just say diff origin master ... and it means git merge base from A to B. And if you leave B out, which we're doing over here, there's no commit B. It just means to the commit I'm running on. So if you run this on the feature branch, it will give you the difference between those two. It's a single command. Very nice. Then the question comes, what tests do we want to run? So we figured out what products do we want to build, but also what tests do we run? And for tests, I have a slightly different definition than most of you right now, because I really don't care about anything below this line, basically. Why? Because I don't have to deploy it in order to run those tests. I can run it in the build. So in the build, I run unit tests and I run integration tests against maybe like an in-memory database or something. I can run quite a large segment of this just in the build of the product. But the top half, I'm going to have to figure out which tests test which product. So it's the integration test that works between different products. So it's going to test 3 different services. How do I figure out which tests I want to run. Usually, you could define it at the product level and say this product helps for this test. But what we did was we introduced a small little file next to the integration test that said, this test requires these products to run. And then when you build a product, you look through all the summations of those files in the tests, and you see, where does my product appear? And that's how you select which test you're going to run. And that way, you're always going to run the minimum amount of tests required for your product. But we have to add a slight bit, which is that if we changed any tests, we're also going to want to run those, right? So we're going to want to run those. Then what do we want to deploy, right? So we figured out which products to build. We figured out which tests to run, but those tests have different required products. It's not just the products that you built. So you're going to want to run also those products that the test requires, basically. And which one are we going to take? The nice one would be if we could say, take the latest. But for the same reason as with the build, we can't, because it's going to change the way when we get along, basically. If a colleague commits to master, then our build and our tests are going to change again, which is what you don't want. Because it's going to be unpredictable, basically. And you're going to end up with API tests that fail, and you have no idea why, but it was because your colleague committed something to master, right? So the same thing applies here. You want to have the difference between you and master on the merge base. So you're going to have to figure out which builds ran from this commit and tag those products with that version number. And you're going to take the builds that you built from the feature along with the builds from this commit from master, basically. Right. Is everyone still with me? This is why it's slightly complex. And this is just in our team, right? So Matt Klein actually refers to a monorepository in an entire organization. But you can imagine that that is many times more complex than the scenario I'm giving you here, which is why it can be a religious effort, a zealot effort in order to build those. Right, so just a quick strategy review. Peter, go ahead.
So for that last part, are you assuming no merge conflicts?
Yeah. How do you mean, are you assuming no merge conflicts?
Comparing with the last, so pretty much the point in master where you branch off, right?
Yes.
But if somebody merged to master after that on the same piece of code you worked on, and it would create a merge conflict.
Yep, so you don't consider those. During your build, you don't consider those because it adds too much complexity. So what you do is before you are going to merge your code to master, you're going to merge master into your feature branch. Then it will run with the merge conflict you just solved in relation to the actual master. So during development, you just develop on the feature and develop with master, which you can't have merge conflicts with because you're based on it. And then when you're going to merge your code, you either rebase or merge. Both strategies actually work. Even squashing works with this strategy. And then you're going to run the most recent one. And you're going to have to do that for every build. It's a little bit of a pain in the ass, but you have to do it. Right, so to recap the strategy, to build, find products based on changes. To test, find tests to run for the products that you changed, plus the tests that were changed. To deploy, find the products required to run the tests. Plus, you're going to have to figure out which versions were of your build and which versions were of the master build, right? Because the products you didn't change, you also have to deploy. There's one little snag still, and that is what happens if you branch and then commit before the master build finishes running. Then the versions that you want to deploy do not exist yet. So you're going to have to make a slight wait where you're going to have to deploy because the master build that you based on has to have finished and deployed its products to the place where you're looking, basically whatever deployment mechanism you have. One thing that's quite painful about that is if someone breaks master, then you merge off it before the build breaks. You now have a broken branch, and you also have to wait for the update master and then merge it back into it. It's kind of painful. All right, so let's try if you can figure it out. I built the Berwout cloud. It's great. It runs a proxy that I love because the Gopher is amazing. It runs my blog, and I have a dinner planning service where I can enter meals, and I can click ingredients, and I can add those, and then I can make a meal, basically. And then I can click a button, and I get 7 meals for the next week, and I have my grocery list, right? It's a nice little application. I can show you how the application looks. Right, made with love by me and my girlfriend, which is the banner at the bottom. You can add meals, and you basically have a catalog of ingredients, which is your grocery store or whatever. You can click ingredients in the catalog, and they will appear in your meal. And we will have a salad meal here, and we can add some ingredients of our own if we want. I hate Witlof actually, but I figure if we're in hell anyway. And then we can submit this meal, and it will be entered into our database. And then when we retrieve 7 meals, we will have a nice grocery shopping list, right? So it's quite a simple application. It uses the ingredient service. I kind of want to go back to my PowerPoint here. Does this work? Yes. It uses the ingredient service to render the catalog on the left that you saw, and it uses the meal service to post the meals towards and later generate the list of meals that we're going to have a look at. And then the blog kind of has nothing to do with it, but it also runs there, and it's also in my mono repository. And the same is there's a little Mongo setup container that is also one of my products, but all it does is it inserts some data into my Mongo in my cluster. And now I have a test, and the test I have is exactly what I just showed you. So I enter that stuff, and I submit a meal, and it tests if the meal is actually posted to the database. Now, I updated the ingredient service. Can someone tell me what's going to build, what tests will run, and what we will deploy? Let's start with what we're going to build. Can anyone tell me what we're going to build?
Ingredient service?
We're going to build the ingredient service. That's true. Anything else? No, correct. All right. Then what are we going to test? Sorry, what tests do we run?
Ingredient service and dinner planner.
Well, the test that's going to run is the test that runs the flow that displays, that posts a meal, right? So the question after that is what are we going to deploy? And you said ingredient service and dinner planner, basically, right?
Deploy would be just the ingredient service, but test would be the planner as well.
Right, but because this is a test environment where we have to test against a specific version of master, right? We also have to deploy the dependent services, the other services that depend on this test. So which services are we going to have to deploy? Right, so the ingredient service, the dinner planner, the meal service.
Yeah.
Anything else?
The Mongo?
The Mongos, exactly. Anything else?
Proxy?
The proxy, yes, exactly, because we're going to reach it from outside of the cluster. Sorry, I didn't tell you that. And we're going to have to also deploy the Mongo setup because it injects the test data into our database, right? So then let's have a look to see that I'm not lying. We have the Jenkins build right here. I only have to have one pipeline because, well, it runs everything I want to run, right? And then I made a diff in the meal service, and we're going to run this build. Don't want to save my password, not ever. And at the start, it's going to tell us products to build, meal service, tests to run, dinner planner tests, which is the test that inserts the meal, products to deploy, Mongo, meal service, ingredient service, dinner planner, Mongo setup, and traffic. So you guys are correct. Great job. So it's going to do all that for me, and then in about a minute it will probably be done. Why so fast? Because it only has to build what we changed and only has to run the tests that we hit. So that's kind of nice. This also enables us to do some pretty funky stuff. Like, because we have tests that run for our products, and after the tests succeed, hopefully we will know that our products are production ready. That's one step I forgot to mention. You're gonna have to trust your automated tests if you want this to work. Because if there's a manual verification after every pipeline you run, I mean, you could put it like on ready for acceptation testing or whatever, and then hand it off to your testers if you want. But it's gonna be much, much, much more powerful if you can say these services are now ready for production and you can deploy them whenever you want. So regardless of deployment mechanism, it just says these services are now promoted to production level. Good luck. And you can do some neat little tricks then. For instance, Maven has a way of saying, update every dependency in this POM file. So what you can do is you can make a build that updates the dependencies, creates a branch, and then when your build succeeds, it merges the branch back in. And you don't even have to touch it. That's great. It's like a dependabot, but it also does your work for you. It's amazing. And it's going to run the tests on all the products that are connected to your product, not just on that one product. So it's very powerful, and it verifies that your things are actually, well, production ready. It's never going to be 100% good because you're always going to miss something, but a human will also always miss something. So you can automatically update a bunch of your services this way, and actually the services that receive the most security feature updates and the most security and the most feature updates, we built this mechanism. And the one pain that you have is if the updating fails, you're going to have to do some work. But you're also going to have to do that work if you ever make a big step up in dependencies. And because you're taking small incremental steps towards your goal instead of one large step, it's going to be much less work, and you can get on the road much faster again. So you can update your dependencies 7 times a week if you want. And it's only going to be one little dependency that fails, and you can just adjust whatever you need.
And how does that work with breaking changes? So
Breaking changes to the API will break your build, hopefully.
Okay, yeah.
So you should actually,
Yeah, you said you still have to implement it.
yes, you still have to do work whenever it breaks, because we can never just trust latest, right? It's going to require work from our side either way, but the amount of pain you suffer when it's just like 15 minutes of checking, oh yeah, this version changed, check the change logs, see what changed in that version, instead of I update my dependencies once every 3 months and here are the change logs, good luck. It's gonna be much, much, much less painful. You can also build in stuff like OWASP detection, which basically, most people, they put in OWASP detection, then see the staggering amount of production vulnerabilities they have, then either ignore the plugin or turn it back off. With this, you don't have to, because you're also automatically updating everything. We regularly had days where there was not one medium vulnerability even. And that is pretty amazing across 40 different services with 5,000 developers on our platform. I loved it. So the 4th step for us, and it had to do with this monorepository that gave us some extra challenges, because if you make automatic builds, those builds are going to require a test environment. We were still working on Docker Compose when this was working, so we had to have different nodes in our test cluster basically, and it was a bottleneck because there would be 3 automated builds running a day, and then someone would also be developing. So we didn't have enough test space. There was a large amount of small changes, which caused us to require more testing space. And we also, because previously we went from a situation where we had to run all the products on one test host. We had these big Bertha hosts with like 45 containers running on them and specs that you would pay for. So to convince our product owner on this one was actually not that difficult, because we could point to the cost that those huge hosts were giving us and say that we can do it much smaller now because we're running smaller change sets on multiple different environments. We still required one for the acceptation environment, basically, where everything runs together, but much less for the rest. So in order to scale the test environment, what we did is we added a little bit of complexity again, because we had to, well, basically we had to, some extra rules. Whenever a branch was made, we would place a reservation on one of our test environments, because they were single host test environments. And then when the branches ran out, we would replace the newest branch, we would wipe the host, replace the newest branch on the new host. So basically, if you were making enough pull requests, you could theoretically bother each other, but usually that was not the case. And also, previously we did not put policies on our hosts and they ran throughout the night. We figured we're adding complexity anyways to adjust scaling in our cluster. We might as well add policies that turn them off. So the first time a branch was created on a day, it would also start up the host. And otherwise we would shut them down in the evening. So sometimes if you only ran like 3 or 4 branches a day, you would only ever turn on 3 or 4 hosts a day, which cost-wise, we went to having one big test environment with a few hosts, and we ended up having much more test environments, but for the same cost, actually. So our product owner was very happy. I do not mean this as an argument to be an idiot at first and not set policies on your test hosts, but it did help for the budgeting on this one. So turning them off at night is a good idea, basically, but I think we can all agree on that. One thing that we used here also was we calculated the costs and communicated them to the product owner, and that was very helpful for us. We had a few instances of projects that ran in our environment, which gradually accrued more test environments, as projects usually do because they grow, and they did not communicate the cost of operating them very well. And in the end, the project's funding almost got cut because they were using so much that the innovation was no longer worth the maintenance it would take to keep the project development running. So be careful about cloud costs, I guess. The 5th step for us was Kubernetes, and it was actually one we were still doing at the time I left the assignment, because it is not a very easy one. It brings great benefits because you can have a multi-customer setup where you can split everything by namespaces and you can isolate very well from each other. You have easier scaling up and down of resources because you no longer have to think about how many hosts are on. You only have to think about what's the number of hosts in my cluster. If it starts getting too crowded, you can add one or you can remove a few. It's actually much easier than managing single hosts. So the complexity of the earlier solution we had for scaling our test environments, it could be thrown away. And throwing away complexity is one of my favorite things to do. Yeah, less complexity managing hosts, and you have a more efficient cleanup on your test environment specifically, because you can start a namespace whenever you start a branch. And when you're done with the namespace, you just throw away the whole namespace, and it's very nice. It is a world of possibilities, Kubernetes. And when you mention it to developers, they're like, yes, and I want to do it, and I want to build this, and I want to use Istio, and I want to use log tracing, and that sort of all the cool features, but it has a very steep learning curve. That's one thing that caused this transition for us to almost take as long as the monorepo transition, I would say. It was pretty long, and we made some pretty glaring mistakes in the transition as well, because the added complexity introduces chaos. The same way the snake did at the beginning with the dependencies, Kubernetes also does this. Production needs migrating. We had a law or a rule in our team, which said that if you don't run it on production, you cannot run it on test, because the way you deploy should be standardized across all your environments. It reduces the amount of chaos you get by so much. So in order to run Kubernetes on our test environment, we were forced to also migrate production, which was, I believe in our case, 700 hosts with many different customers and many different services. So this took quite some work. And like I said, it adds complexity in a massive way. Developers have to learn a whole new paradigm, a whole new way of writing down their configuration, managing your versioning, handling deployments. Usually, developers are very used to having deployments that give you a direct result. So you deploy somewhere and you receive a response whether the deployment went okay. In Kubernetes, you have to ask for everything. So you deploy something and you have to ask, did that deployment succeed? Did that deployment succeed? That sort of stuff. You have to pull all the information out of Kubernetes, which is, it's like, well, it's a bit of a burden, but it also like, it makes sense. All right, so looking back. We had the snake that poisoned our work, which is usually the introduction of chaos, but it can also be the flip side. It's totalitarianism. The way you specify so many rules that there is no room for creativity or chaos or actually doing your work. So it can go both ways, and be careful to employ the least amount of process needed and the least amount of complexity needed to solve your problem. So walk in the middle between chaos and between totalitarianism. More chaos means you need more rules. Too many rules means you need more chaos. And actually adding junior developers that kick and scream at things can help. So we saw the guardian of production, and this is something I see in many of my coworkers that have not had the experience of running production for a while. It's that they are scared to touch it. They're scared to touch their deployments because they have been going well and they don't want to change it. They're scared of changing their process because it isolates them from having their customers scream at them. They're pretty scared. So in order to make this change, you have to pass the fear check. You have to pass the three-headed dog, Cerberus. And also, you have to convince Hades to let you do the changes. And it can be the hardest thing ever sometimes. In order to work on a build, like it doesn't add production value, or at least that's not how the product owner usually sees it. I was sort of lucky with my product owner because he used to be a software engineer and had 12 years of experience as a software engineer and a massive beard. So, I mean, that's a big positive. So the way we convinced the product owner, there were a few in the steps we did. There was pointing at production issues, which was the first change. It's usually pretty easy to point at production issues and say our process is causing them, and then give that as a reason to change. The second one we had is we snuck it by in 4 hours that we were not supposed to do the work. I can not recommend getting caught with your pants down. That's the only thing. Sometimes you will be forced to sneak it by, I feel like. I was lucky that I had an understanding product owner. You can point to overwhelming benefits, which was the monorepository. We promised him a dream. It's sort of a religion. I'm still like, it adds complexity in a massive way. Anyone that comes into the team will need to learn how the monorepository works. We'll need a presentation like the one I just gave you. And then they're still not going to understand the internals, but they're at least going to understand what it does, right? We communicated cost in the fourth one, which was very valuable. We said we can add benefit to the system, the testing system, without actually bringing higher costs. And the last one, Kubernetes, what we did is we were very concrete about what we're going to run on Kubernetes the first round and make a concrete scope that is like actually tiny. You're not going to implement all the fancy stuff that you want. You're just going to implement the bare minimum to show him that it works. And then you're going to take small steps forward like we did out of hell in order to build the cluster, basically. So basically, what I wanted to say was that if you are a junior on a team and you want to change all of these things, it takes a hero's mentality to go into hell and to bargain with Hades in order to let you bring the environment out of it. And I hope that some of the things I said here, even the concrete solutions I showed, will be of benefit to you. Do consider the thing I said at the start, is that your organization shapes the solution that you will make. So you will have to adjust your situation based on the communication barriers that you have in your team. Finally, all the monorepo stuff is available on my Git if you want to take a look. Because one thing that bothered me was that big companies usually don't share this kind of stuff. They have very large build environments themselves, like Google has Borg, which does basically this, but on a much more massive scale, which we don't actually need. So, but it was hard to find things that build monorepos. There is NGRX, or no, sorry. What? NX, exactly, that builds front-end applications. But the nice thing about this one is that it delegates the builds to the products themselves, and they define their own Jenkins parts, and you can build whatever you want in there. You can also do NX inside this monorepository if you want. So it gives freedom to the builds and to the tests. And one thing I didn't show is that it also, because the builds are isolated from each other, they don't require a deployment or anything, they can all run in parallel. And because the tests, in my case, do the same, they can also all run in parallel. In some cases, the integration tests and end-to-end tests will not be able to be run in parallel due to data restrictions or whatever. You're going to have to employ some sort of locking. We had that as well at our solution, actually. We had a few builds that use Jenkins locking mechanisms in order to build at the right time, but it will increase your build time and your complexity, so it's painful. We also had builds that depended on each other. So we had one that built a container and then one that ran on that container. So you also sometimes might have to put a priority in your builds. So what we did is we said these builds are of priority 1, which means they're required for builds later on down the pipeline. And then we ran a parallel stage 1, parallel stage 2, parallel stage 3, and then tests. So this just showed you the builds. There's also much to say about deployments, but I'm going to leave that out for now. Thank you for your attention. Any questions?
I've got a question. So if you're a team of 4 or 5, you can manage one monorepo, I guess. But let's say you want to do it on a bigger scale. How do you manage, let's call it multi-tenancy? Like if you've got 100 developers on one big monorepo, who's going to be in charge? How do you manage this one big repo with 2, 3 pull requests per hour maybe?
Yeah, it was a question I sort of expected. And I think I would say don't. Because the complexity required to deal with those sort of things, I'm sure you can probably do something like have change sets queued in a way, so you submit them for build, and then you queue them so that they run through the build sequentially, and then you can probably also determine which change sets are going to hit each other. And then when your change set's turn is up, basically, you get feedback from the build system about what happened to your change sets. So it could happen that a change set ahead of you in the queue destroyed your build, And it's going to be painful, but the queuing mechanism is at least going to allow you to do the kind of thing you're looking for without going completely mad. But like building a queuing system for changes, I believe at GitLab they have that, but I think it requires some excellent software engineering and some very good communication skills to get the teams what they need. And you're also going to have to think about what are you going to log in the build? Like if you log any sensitive information that cannot be leaked outside of your team, it's going to be difficult. So authorization, who has access to run the builds? Who gets to read the logs? What portion of the logs do they get to read? It brings a whole bunch of extra security questions with it that's going to make it very, very painful. And it will be like a religious undertaking. You will all have to believe, and you will all have to build a massive church that is your build system.
Okay, so in that sense, you're saying one monorepo per team.
Yes, and actually, when I started with the monorepo, I said we should build a monorepo because this is great, right? I was a little bit like, I really loved the idea. And then my senior dev that was working there for 10 years already in the same department, he sat next to me and he said, all right, but we're gonna need at least 4. Because he envisioned the way that you split the build. So for instance, we do split, like you see, I have the monorepo, but I also have the deployments separate because I want to keep, because in Jenkins, it's very annoying that when you build on commit, it's like you're going to commit to this repository in order to set your test environment up, but then it's going to trigger a build, right? So for practical reasons, like I call it a monorepo, but in essence, it's not. It's like an in-between. And it's what the least complexity required for us, right? So for your situation, if you have 100 developers, it's going to require something much more complex. And it's probably going to require multiples, even though you call it a monorepo, right? All right, thank you very much. Enjoy the drinks that are left over, and feel free to ask me anything about any of the practical solutions or debate with me about the chaos versus totalitarianism thing, because I kind of like that view where you walk in the middle and try to find your way. Thank you.
Thanks very much.